Hi everyone, my name is Walid and I'm a civil engineer in UK. So in today's video I'm going to show how we can design Swale in InfoDrainage. It's basically the SuDS design basically, and also these are called LIDs, low impact developments in the USA, and in the UK is called SuDS, sustainable drainage systems in the LIDs. So this is basically takes the water from from upstream to downstream. These are not basically the storage, but these are basically helps in flowing the water so that the quality of the water is maintained. So let's get started. So I have this InfoDrainage model. If you are following the previous video where we have already designed the pond, and in this video I'm going to show how we can design the swales or the SuDS model into our InfoDrainage. So let's get first thing first. So first of all, I am going to do the phase management. I am going to create a new phase. So click this one, and then just I will duplicate this phase and rename this one as my SuDS design. And yeah, and I will just turn off this one and make it stop. So phase management works in InfoDrainage as in AutoCAD we have layers. So we make different layers so that it's easier for us to analyze, and that if something went wrong we can go back and utilize separately. For example, pond design, you just turn on pond, and from here you can set to the which phase you want to work on. So this is helpful. So this is how we create a phase in InfoDrainage, and now I will just close this one. So I will also import my surface as we previously did. So the same method, same surface, keep all. Now my surface has been, you can see the surface is in the background. I will just switch off this one, and I will also bring in the CAD outlines to design the swale. So go to the CAD, import data, and then I have a SuDS outlines. I will click OK. At the time I don't want all of these layers, so I will just deselect and go my stormwater controls. I will click on this one, and you can see I have the outlines. The better way to say, if we can just turn off our catchments, inflow areas. Now you can see this is where we will draw our swale, and here we will create our cellular storage porous pavement. I will make next video on this one, but in this way we are going to focus on our swale. So in order to create the swale, I will just delete my pipeline that was going from this one, and then like we did from the stormwater controls on the left, we have all these features from the pond and everything, and we are going to design swales. So we will just drag this one, and to start snap, if the snap mode is turned off, you can just snap it from here and start snapping. But in the pond we digitize like whatever you want to digitize, but in swales you have to first mention the width. So first click is here. So this is the upstream and this is downstream. From the upstream we will first select the 1 point, and the width not going this way, but we will go this way. So first is my second point is this one, and then you will just able to see like how it's working. And then this is the length we want. So first we will click for the width, and then we just 2 points and then just drag, and I will just snap it here. I will click here and it will automatically created the swale. So I will right click and use the select tool, and on the right side at the bottom you can see the roughly properties of the swale that we have just created, and also you can see the properties after double clicking on the swale. And this exceedance level that was automatically calculated using the surface that we have already in the background, and I just want to select the depth as for previously, And for the base, I have already calculated the value. So base is my 35, and I will put as base, and the side slopes is 1 in 1. So these are the side slopes, and 1 in 1, and then the longitudinal slope. From here to this way, the slope of the longitudinal slope is 1 in 1000, and this calculates the length as well. We don't need the freeboard, but the Manning's roughness I will go with 0.20, as we have for the pond is 0.30. Now this has roughly calculated our values that we put, and if you will have a look at the bottom, we also have the total volume, that is 184.193. I will just make a note, 184.193. So this is our swale volume that we have here. So this is the volume in meter cube. And then if I go to the advanced settings, so in Swale what happens is basically, so you can see these are the vegetated areas. All of this is vegetated, this is vegetated, this is like vegetated or green. So water will not stay like in the pond, it will infiltrate. So some of the water will infiltrate into the ground, and some will infiltrate from the sides. So we have the infiltration. As long as water pass from upstream to downstream, it also infiltrate into the ground and to the side slopes. This is why we also design swales, so that water we can control the risk of flooding. So we have to put the values for the infiltration, and the values of infiltration depends on the soil. Obviously, if it's a clay soil, so the infiltration will be less, and if the soil is sandy or gravelly, then you will have more infiltration. You can have that from the geotechnical reports and the ground investigation reports, but I also already for this one we will just use the values. So for the base I will use at 0.02, and with the side slopes the infiltration is 0.02 meters per hour. I also have the safety factor of 2. So the safety factor of 2 means 0.02 divided by 2. So the base infiltration will be 0.01 basically. So this is our real values because we have put the safety factor of 2. And then the porosity is 100%. This is all good. Now we have to connect the inlets and outlets. So we'll just quickly do that. And if you are not sure what feature you are doing, if you will just click on the image, it will show you what are the side slopes or what are the infiltration trench. If you want to put what are the exceedance level and the length, the slope, and these are the side slopes. So we have 1 in 1 side slopes, and this is the slope that we have is 1 in 1000. So this is very helpful for every stormwater feature in the InfoDrainage. So I will just close this one. All of these are okay. Now we will just quickly draw our inlets and outlet pipes. Again, I also have the CAD drawing for that. I can use the surge pipe. Click on the next. It will just taking some time to load, and once it will load, we can just design over this one. And also in the previous video we have calculated the runoffs. That was 16.1, but we have to do it again for this side. So I have already there. I will just click on the finish. You can see I have got these pipe links to connect. So I will just quickly, you can do from the top as well, or from the connections on the right, whichever is suitable for you. And first start from the upstream and then snap it here. If you will snap inlet, again click from this one to the outlet. So we'll just click on the inlet, as this is an inlet. So again change to the select, double click on the pipe network to see the pipe. So we have this pipe, and we should change it to 300. Click OK, and if you want to change from the table, or double click to find the pipe, so that will be helpful. So this is also 300, and this way we can create a swale. But I would like to design the orifice for this one as we did for the pond, and that way we can have some so that we can make the best use of our swale. Otherwise the water will be flowing, so it stores some of the volume, and then orifice will help to discharge that into the downstream network. So how we can calculate that? So first of all we have to calculate the discharge. First we have to calculate the discharge pen. So discharge. So I am just going to calculate the discharge, and and then for that one I will just go to the stage storage. Discharge is prelim sizing, quick discharge estimate, and we need the data. So for the data user input we need to calculate the area. To calculate the area we need the calculate for the upstream area, and for that we will just use the flow path. At the S1 you see it blue changes to green, it means we have on the manhole, and the downstream is this one. And just click so this is our flow path. I will right click, select tool. Now we have our flow path, and now we can see the inflow summary. From the inflow summary we can see this is the area analyzed. This is a flow path area that we are going to use, 0.654. Another area 0.654 area, so that we can remember 0.654. Click close, and then double click. Sorry, prelim sizing, quick storage, input. So the area was 0.654. Volumetric runoff coefficient, I am going to use, this is a dry period, that is and I am going to use for the winter, that is 0.840. Again this is the volume, means 84% of the volume will flows into the swale during the wet seasons. And the discharge limit for the pond we have calculated that it was 16.1, but this one I would put like 6 or 7, and then we will work back like whichever suits us. So 6 I would say. Infiltration as we put 0.02, safety factor 2, rainfall information we have this one. Again you can put your own rainfall data from your from whichever region you are working, and then calculate accordingly. So quick storage, now it has says that this one, that with the infiltration we have 128 meter cube to 2017 meter cube, sorry, to 217 meter cube. So what was the volume of our swale? If you remember or not, that's why I already make the notes. So 184 meter cube. So we can have the capacity of 184 meter cube in our swale, and it shows that this storage will be 128 to 217. I will click OK. What I can try again is, let's do the lower the discharge rate, try to fix it within our range so that make best use of our swale. I will calculate again. So it says 154 to 245, and it's still in our range, that is 184.193. So I'm quite happy with it. So this is how we can work through it. And this was infiltration, sorry, infiltration rate is 0.02, and then 0.84, 0.65 for quick storage. Everything is good. Sorry, now it's 136 to 232. It's good for our storage volume. And so we are going to use the discharge volume of 4. So we will just put the discharge volume. Discharge will be 4. So we are going to use 4 liter per second to design our orifice. So double click on this one, outlets, pipe free discharge, change it to orifice, and the diameter we are going to calculate. So design depth is 1 meter, and the limit of discharge as we have calculated is 4, so 4 liter per second, and it comes up with the diameter 0.044. so this is very small diameter, like 44 millimeters. We can use gauge in front of that, but for the real world, but this is how we calculate the sizing for our outlets. For the inlets, it's the point inflow, and I will just click OK. Now our swale has been is ready, and you can see this has been changed to orifice. We will just check the analysis criteria, and if you are happy with the analysis, we can just run the simulation and also validate that everything is fine. So this is how we can design the swales. If you have any question, just ask in the comments. In the next video I will create the cellular storage porous pavement for this area. So guys, see you in the next video. Thank you for watching. Peace out.